This is Learning Assessment Problem 810. In this problem, we'll apply the problem-solving strategy of combining complex impedances and admittances. We are requested to determine the total impedance observed at the terminals of this connection of various impedance types. To simplify our discussion, we'll name this series connection of impedances on the right side ZS1, and this pair of series connected impedances on the left ZS2. So our ZS1 is comprised of a 4 ohm resistor plus a 6 ohm inductor minus a 4 ohm capacitor. And this is equivalent to 4 plus J2, and in the polar form this is equal to 4.472 at an angle of 26.57 degrees, and those would be ohms. We can calculate the admittance of this impedance, just the reciprocal of that ZS1 term, and that is equal to 0.2236 at an angle of minus 26.57 degrees, and the units there will be Siemens. And finally, that YS1 can be written in the rectangular format as 0.2 minus J 0.1 Siemens. Now the second impedance combination ZS2 is equal to 2 ohms plus J 2 ohms for the inductor. The admittance of that, the admittance of YS2 is equal to 0.25 minus J 0.25 Siemens. We have these admittances written in the rectangular form because they are connected in parallel in the circuit, and we therefore add the admittances. So we have YS1 plus YS2 is equal to 0.45 minus J 0.35 Siemens, and we'll call this just Y12. And back to the polar form for that admittance, we have 0.570 at an angle of minus 37.85 degrees Siemens. Now we can talk about an impedance Z12, which is equal to ZS1 in parallel with ZS2, and that will be the reciprocal of this parallel admittance term, which is equal to the reciprocal of 1 over 0.57 at an angle of minus 37.85 degrees, or Z12 is equal to 1.754 at an angle of plus 37.85 degrees ohms, and this in the rectangular form is 1.385 plus J 1.076 ohms. Now we're ready to look at the entire impedance. Z sub t will be equal to this Z12 combination plus the remaining 2 ohms in the circuit, and this will equal 2 plus J0 for the resistor term plus 1.38. and this will equal 1.385 plus J 1.076 for the Z12 plus 2 plus J0 representing the impedance of that 2 ohm resistor, and this is equal to 3.8 and this is equal to 3.385 plus J 1.076 ohms.